Okay, so we are discussing that in this the lumen of thylakoid which have water, then this water is breakdown, that is breakdown, and then we get this equation. So we were telling that the photolysis is simply what it is, a process. It's a process in what? It's a process in the presence of water, and in the presence of, sorry, in the presence of light. Like the water is breakdown, and what, when there's a light, the water will be breakdown. Where it will be breakdown? It will be breakdown in this lumen of thylakoid, and then this would be associated. This complete breakdown would be associated with PS2. PS2. Okay, then let's move towards a written theory. Like the complete overview, we know. Uh, wait. Okay, so first thing, we know in the night there is no photosynthesis process, and I'm sure everyone knows that. No process, no. But what process is that then? We have respiration. We have respiration process in the night. Okay, then our complete light direction was, the target was to form ATP. Target was to form ATP. Why we need to have that ATP? To fill lumen of thylakoid with H positive ions. Simply, target was to make an ATP and to fill lumen. As we know, we discussed, we have the lumen here, and lumen only need H positive ion. They have a water would be breakdown, two hydrogen, one would be given to another thing. In C3 cycle we need to give like, three carbon are there, then will be taken five carbon. A lot of process would be happen in the dark reaction as well, which will be our next topic, I'm sure. Then to fill lumen of thylakoid with H positive ions, and then we, like this lumen of thylakoid only need H positive ions, and our target is only that to fill to recover that. So ATP, which would be filled with the lumen, which would ATP would be in the lumen of thylakoid, which would be filled with hydrogen, H positive with hydrogen, and so there will be lower concentration. So they would be having lower concentration of H in stroma, and stroma is a matrix. If all the complete H positive ions are taken in the lumen of thylakoid, so there will be low concentration of stroma, where low concentration of hydrogen, where that will be stroma. So lumen have high lumen high concentration as compared to the stroma. This is very important MCQs, I think. And then we have PS2, which will we have PS2 which will take H positive ions. Then like a little bit, H positive ions are in the stroma. So still, of course, everywhere they get H positive ion, the lumen will take. So in the photosystem 2, they have one hydrogen which will be in the stroma. So they will send to the cytochrome. Send to cytochrome. They will send to the cytochrome, and then this will use, or then it will go again to the same as I just told you, to the lumen. Same goes to lumen of thylakoid. Okay, then it will again go to where the plastic one and the PQ particle we have. Okay, this is a complete process. I've discussed just writing a little theory to get it easy. Then we know the concentration of hydrogen in lumen. Concentration of hydrogen, H positive in lumen, will increase by three ways. Increase by three ways. By three ways, and we'll discuss that in the coming video, just because I'm sure we don't have much more time. So the concentration of hydrogen in lumen, how? Of course we know, if the everywhere they look into, they got hydrogen, they will absorb, not absorb, but they will take it. If they if this is simply stroma, the part, oh god, this